Somewhere right now, the question you just typed into a chatbot is setting off a chain reaction most people never think about. A building wakes up, cooling systems kick into gear, tens of thousands of chips begin running trillions of calculations a second, and in some places, millions of gallons of water start moving through pipes, just to keep the machines from melting themselves. We call it the cloud. But there is no cloud. There's a fast-growing network of windowless buildings scattered across the planet, packed with some of the most powerful and power-hungry machines humans have ever built. And right now, the 5 biggest tech companies on Earth are on track to spend more building these buildings this year than the entire economy of Argentina produces in 12 months. This is the hidden cost of AI, and it isn't measured in dollars alone. It's measured in megawatts, in gallons, and in the strain on power grids that took a century to build. Cloud computing might be the most effective piece of branding in tech history. It sounds like nothing, weightless, invisible, something that lives up there, somewhere, made of mist. But everything you just heard happens on the ground, in a network of windowless buildings the size of shopping malls, packed floor to ceiling with racks of specialized chips called GPUs. Each one is built to do one thing extremely well: run millions of calculations in parallel, which happens to be exactly the kind of math an AI model needs to think. And the companies racing to build the most of these buildings, OpenAI, Google, Microsoft, Amazon, Meta, aren't spending in the tens of billions anymore. In 2026 alone, the largest players are on pace to spend in the neighborhood of $700 billion on this build-out, combined, in a single year. That's the figure that rivals a mid-sized country's entire economy, poured into warehouses full of chips. Why? Because in the race for AI dominance, computing power has become the new oil. Whoever controls the most of it trains the bigger models, answers the most queries, and pulls further ahead. It's an arms race, except the weapons are server racks, and the front line is wherever land, power, and water happen to be cheap enough to build on. But there's a catch. All of that computing power has to be fed, and what it eats is electricity, in quantities that are starting to alarm the people who run the power grid. Here's the difference between AI and the internet you grew up with. A normal web search mostly retrieves something that already exists, a page pulled off a disk and sent to your screen. Cheap, in computing terms. AI doesn't retrieve, it generates. Every response, every paragraph, every image, every line of code is a fresh calculation, run from scratch, across a stack of chips drawing power the entire time. Multiply that by hundreds of millions of users sending billions of requests a day, and it stops sounding like a tech story and starts sounding like an energy story. Here's one way to picture it. A typical large data center already uses about as much electricity as 100,000 homes. The newest AI campuses, the ones going up right now, are designed for 20 times that. 1 gigawatt from a single site, around the clock. A gigawatt is roughly what one large nuclear power plant produces continuously, and several campuses at that scale are coming online this year. Zoom out further, and it gets stranger. Add up every data center on the planet, and by some estimates, they'd already rank as the world's 5th largest consumer of electricity. Bigger than all of Russia, just behind Japan. So utilities are scrambling. New transmission lines, new substations. In some places, entire new power plants, built specifically to keep these buildings running. But electricity turns out to be only half the bill, and the other half is about to land somewhere far more personal than a power grid. It's about to land on your kitchen table. In Manassas, Virginia, a man named John Steinbach opened his electricity bill in January and didn't believe what he was looking at. The month before, he'd paid around $100. This one said $281. He's lived in that house for almost 40 years. He'd never seen anything like it. He's not imagining it, and he's not alone. Since 2021, the average American electricity bill has climbed nearly 40%, the fastest run-up in decades. And in the areas closest to the data center boom, it's worse. Household prices are up more than 90% in Washington, D.C., and over 70% in Maryland. in just 5 years. Across the river, Virginia now hosts roughly 600 data centers, with another 100 on the way, and those facilities alone account for nearly 40% of the entire state's electricity use. So, is this AI's fault? Here's where you should be suspicious of anyone who gives you a clean answer. One widely shared claim says people near data centers are paying 267% more than 5 years ago. That number is real, but it's not your bill. It's the wholesale price utilities pay on the open market, which is only one slice of what shows up on your statement. Meanwhile, a study commissioned by Amazon found its own data centers fully cover their own power costs, and even throw off extra revenue utilities can use to upgrade the grid for everyone else. But here's the mechanism actually driving this, and it's 100 years old, long before AI existed. When a utility builds a new power line or plant, it doesn't bill one customer. It spreads the cost across everyone on the grid. Normally that's fair. Everyone benefits a little from a stronger grid. The problem is scale. A typical new customer might need a few megawatts. A single AI campus needs 1,000. When demand jumps that fast, wholesale prices spike, and those spikes flow straight through to your bill, exactly the way they always have. The system noticed. In the first 3 months of 2026 alone, utilities asked regulators for over $9 billion in rate increases, on top of a record $31 billion the year before, much of which hasn't even reached your bill yet. Lawmakers in more than 30 states have introduced over 300 bills trying to get ahead of this. And in Georgia, where electricity prices jumped 41% in 4 years, voters did something rare. They voted the regulators who approved it out of office. Even the White House stepped in. Earlier this year, the president brought AI executives to Washington and got them to sign something called a Ratepayer Protection Pledge, a promise that data centers, not households, would cover the cost of the power they use. Microsoft and Anthropic have each made similar commitments on their own. Whether those promises hold is the multi-billion-dollar question. For a century, the deal was simple: spread infrastructure costs across everyone, and bills rise slowly and predictably. AI just added a customer 20 times larger than that deal was ever built for. And right now, in state houses and utility commissions across the country, the system is scrambling to work out who picks up the difference. But the electricity bill might not even be the most personal cost. Because in some towns, the fight isn't about the price of power. It's about the water running out. Two of the largest reservoirs in North America, Lake Mead and Lake Powell, are running historically low. Lake Mead sits at about a third full, Lake Powell below a quarter. The federal government has formally declared a shortage, forcing Arizona to give up nearly a fifth of its annual water supply. That's the backdrop for one of the fastest data center booms in the country, in Phoenix. Right now, data centers around Phoenix use about 385 million gallons of water a year for cooling. One projection shows where that's headed: 3.7 billion gallons a year, an increase of roughly 870%, nearly twice the entire water supply of a city the size of Flagstaff, just for server farms. Here's why they need it at all. Racks of GPUs throw off enormous heat, and the cheapest way to remove it is evaporation, the same principle as sweat cooling your skin. Water runs through the system, absorbs the heat, and roughly 80% of it evaporates into the air, gone for good. A single large facility can use up to 5 million gallons a day, about what a town of 10 to 50,000 people uses. So, disaster, right? Here's where again you should slow down. Look at the actual numbers today, not the projections. And data centers across the entire county that contains Phoenix used about 900 million gallons last year. Total. Roughly 0.1% of the county's water. The biggest water users in the region aren't data centers at all. They're golf courses, power plants, and mines. So which is it? A rounding error or an 800% disaster? Both, because they answer different questions. The 0.1% describes today. The 870% describes the pipeline, the data centers already approved, financed, and under construction. And raw percentages hide something else. During a declared shortage, water isn't interchangeable. A gallon a golf course has drawn for decades under an old water right is not the same, legally or politically, as a gallon a brand new data center wants to start drawing this year, in a basin the federal government just ordered the state to draw less from. And here's a twist that loops right back to the power bill. Some analysts argue water is the wrong thing to worry about entirely, that the bigger hidden cost isn't the water inside the data center, it's the water used by the power plants generating its electricity. By one estimate, electricity generation for U.S. data centers consumed over 200 billion gallons of water in a single year, far more than direct cooling ever does. The fight over the tap in your backyard might be a distraction from the fight over the power plant 100 miles away. Either way, the people closest to it aren't waiting for the debate to settle. Cities across the Phoenix area, Chandler, Mesa, Avondale, have already capped how much water new data centers can draw, or require developers to bring their own supply. In Arizona and outside Atlanta, entire hyperscale projects have been blocked or scaled back, not by Congress, not by a court, but by a local water utility running the numbers and saying no. The cloud was never weightless. It runs on chips that cost more than the output of entire nations, on electricity already showing up on bills in Manassas, Virginia, and on water already being fought over, gallon by gallon, in Chandler, Arizona. The most powerful technology ever built turns out to be remarkably down to earth, fought over, watt by watt and gallon by gallon, in towns most of its users will never visit. And that points to something bigger than any single bill or any single basin. Because underneath all of it, the chips, the electricity, the water, this isn't really a story about artificial intelligence at all. It's a story about something much older. For most of the internet era, software was the ultimate business. A small team could build a product, deploy it online, and reach millions of users, without building a single factory, railroad, or power plant. The digital economy seemed fundamentally different from every industrial revolution that came before it. AI is ending that illusion. Unlike traditional software, artificial intelligence scales through physical infrastructure. More users require more computing power. More computing power requires more chips. More chips require more electricity. And more electricity requires more substations, transmission lines, power plants, and data centers. The future of AI is starting to look a lot like the past. The railroads of the 19th century, the oil industry of the 20th, the telecom networks of the early internet. Every transformative technology eventually becomes an infrastructure story, and right now, the largest companies on Earth are racing to build that infrastructure before their competitors do. Here's how fast this happened. 3 years ago, AI data centers used about 4% of all the electricity in the United States. Today, it's over 10%, more than a doubling in roughly the time it takes to build a single power plant from scratch. No utility on Earth plans for that kind of curve. So the companies driving it stopped waiting for utilities to catch up and started building power plants of their own. Microsoft, Amazon, Google, Meta, and OpenAI aren't just investing in software anymore. They're buying land, locking in fiber routes, securing water rights, and increasingly, building their own power plants. Microsoft is bringing the 3 Mile Island plant back online, the first restart of a retired U.S. nuclear reactor in history, under a 20-year deal, specifically to feed its AI data centers. Amazon has put roughly $20 billion into turning a single nuclear site in Pennsylvania into a dedicated AI campus. Google and Amazon are both betting on next-generation mini-reactors, while Meta has lined up deals for more nuclear power than any company in the group, enough, eventually, to electrify a small country. Across the industry, Big Tech has now committed to nearly 10 gigawatts of new nuclear capacity in a single year, more than the entire country built in the prior decade. This is why utilities are racing to expand capacity, why towns are competing to host data centers, and why a patch of land with cheap electricity and water access has become some of the most valuable real estate in the digital economy. The question is no longer whether AI will reshape the world. The question is whether the physical world underneath it can keep up. Can the grid expand fast enough? Can communities provide the water? Can infrastructure built for the 20th century carry the technologies of the 21st? Because every AI breakthrough, every model, every answer, every wow moment ultimately depends on something far less glamorous than an algorithm. A power line in Virginia, a water pipe in Arizona, a reservoir that's a third full. The cloud was supposed to free technology from the physical world. Instead, it's pulling the physical world back into the center of the story. One substation, one water right, one electric bill at a time.